Hello, this is an introduction to buttons with Raspberry Pi and Python. Push buttons are very simple, yet there is a lot of confusion about them. I hope that this video will dispose of some of the confusion out there. The top search result for Raspberry Pi buttons on YouTube today is a video released about 3 years ago that contributes to that confusion greatly. And this video is actually one of the better ones out there. I have typed up the tutorial code and tried it out. Here it is. The LED comes on as long as I depress the button. Okay, nice. But what next? By the way, if you find the placement of my button on the breadboard strange, that's because my button has only 3 pins. One of the pins has been removed. This way I cut down on the wires and I can place my button at the edge of the breadboard. But I digress. Back to my rant. That's a lot of code to do very little. Let's face it, in this scenario, you don't even need a Raspberry Pi. The Raspberry Pi here is reduced to a battery. Sadly, there isn't much more we could do with this tutorial to take it to the next level. I do not wish to pick a bone with this specific tutorial or this specific YouTuber. This is just an example of a common problem. This is just wrong. This is not how this is supposed to be done. There's no other way I can put it. From an educator's perspective, exposure to bad tutorials like this one I'm talking about early on does a lot of damage. They form bad habits which are difficult to reverse. I spent considerable time and effort in my college teaching to reverse that. I have 2 major issues with this approach. First of all, I don't like the ham-fisted while loop. If you use an infinite loop in your Python code, or any other programming language for that matter, your program can only do one thing. I don't know about you, but I would like my Raspberry Pi to do more than just monitor whether a button has been pressed. A loop like that is a dead end. If you wanted to add anything else, even as simple as a second button, and try to make it work independently from the first one, you can forget about it. This is not the way to go about this. If you insist to have such a loop in your program, it should at least be running as a separate thread, so it can run concurrently with other code, including some other loops, if you so desired. The other issue that bothers me about this code is the usage of RPi.GPIO library. Tutorials using the library are everywhere. RPi.GPIO may have made sense when Raspberry came out in 2012. Back then, we didn't have much choice. A bulk of initial libraries and tutorials was developed by Arduino enthusiasts with Arduino's specific coding style. Unfortunately, it's stuck and it continues to plague us until today. This is why we have multiple pin numbering schemes, and this is why we have awful code like that. Arduino and the Pi are different. You are only as good as the tools you use, and RPi.GPIO is not the best library currently available. To me, RPi.GPIO is C that looks like Python, minus the semicolons. I might as well use C. It will be more efficient and run way faster. The gpiozero is a much better choice when programming in Python with Raspberry Pi. Created by people that actually worked for Raspberry Pi Foundation, it utilizes full potential of the Python programming language, and it allows for flexible, asynchronous programming model using very simple code. gpiozero documentation is fantastic and has a lot of examples, a great resource for beginners and experienced programmers alike. Let's have a peek at the gpiozero website now. The button information is found under API Input Devices. I will leave the detailed reading to you, but give you a quick summary now. gpiozero buttons are event-driven. This means that you can register one or more events, such as presses and holds for a button, and associate actions with them. Event-driven programming is very straightforward, and it does not require the programmer to create loops that constantly check whether a button has been pressed. Instead, it is the user that triggers the appropriate code through interacting with the physical button. Let's rewrite the initial example using gpiozero, starting with a basic skeleton program. Looking at the schematic diagram, my button is connected to pin 21 and the LED is connected to pin 26. Unlike with RPi.GPIO, I do not have to worry about pull up or pull down resistors. I can rely on the default, which is pull up, by the way. This is why the button is wired to the ground on my breadboard. The gpiozero equivalent to the infinite polling loop in the original example is only one line of code. This line of code ties together the LED to the button, where the button will communicate with the LED automatically every 10 milliseconds with minimal system load. By default, the LED has the value of 0, which means it's off. When I hold the button, it passes the value of 1 to the LED, turning it on. Since this is a new program, I need to give it execute permissions before I can run it. Let's run it now. As you can see, this works just like the original example, but with a lot less code. Yet, clearly, many people still insist that the first method is better. Maybe I am missing something. I don't think so. The event-driven programming model for buttons is very flexible. Most often we specify what happens when a button is pressed or held, but there are other events available. The simplest event to demonstrate is a button press, a click. The event setup is done once, at the beginning of the program, or at least before you expect the button to be pressed. This event gets a callback, which is the name of a function that will be called when the event is triggered. For example, I can instruct the button to turn the LED on when it is pressed. It is very important to note that a callback function is not executed when it is registered with the button, but rather only and if the actual event happens. This is why there are no parentheses here at the end of this line. Including the parentheses here is a common mistake. Let's see how this works. The LED came on and stayed on when I pressed the button. The LED is actually turned on with every additional button press. It's just not apparent if the LED is already on. Turning the LED off would require additional code. The callback can be any function you like, as long as it doesn't receive parameters. For example, I can change the LED on to LED blink. Let's see how that would work. I've mentioned earlier that the callback function cannot have parameters. This is actually not true. The program will run, but it will not behave correctly when parameters are introduced. Let me demonstrate. I will attempt to change the blinking interval from the default 1 second to a faster cycle. As you see, there was a warning from Python about the parentheses, but more importantly, the LED started blinking right away without me pressing the button. Python 3 has a new keyword called lambda, which can be used to overcome that limitation. Using lambda allows to have the proverbial cake and eat it too. We can have callbacks with parameters after all. Have a look at how the program behaves now. Even when using lambda, you are still limited to one action per event, tied to an object such as an LED. If you would like to execute your own code, presumably consisting of multiple lines, you can put that code inside of a function and use this function's name as the callback. Let me modify the code to illustrate that. I will add a second LED to the breadboard and have them blink alternately to make it more interesting. Here is the updated code. I have added a second LED to pin 19, plus a few additional lines of code, including an extra import for sleep delay. Let's see how this new setup works. As you probably expected, the LEDs blink alternately. It got a bit messy when I pressed the button again with the blinking on. Ultimately, I would like this button to start and stop the alternate blinking action. This can be done in several ways, but the simplest one relies on a variable which will keep track for me whether the LEDs are active. Have a look at the updated code. I have a global variable called blinkOn, which is set to false when the program starts. The blinking will start only if this variable is set to true. The last line of the function flips the blinkOn variable to the opposite value with every button press. So, there it is, my simple guide to buttons with Raspberry Pi and GPIO 0. Are you less confused? Let me know by posting a comment. Please have a look at the videos linked at the end for more advanced tutorials. Thanks for watching.